Hello and welcome to today's session. This session focuses on Learning Outcome 1 LO1. Understand the core principles of computer networks. In this video, we will explore how computer networks enable seamless communication in our digital world. You will learn about the key principles of networking, including connectivity, protocols, and security, and understand how these elements work together to make global communication possible. This unit introduces the foundational principles of computer networking. Learners explore network models and the layers within them. Focus is given to the TCP/IP model and its protocol suite. Key protocols such as Ethernet, IP, and TCP/UDP are highlighted. The unit culminates in designing a practical computer network. Network models are frameworks for understanding data movement across networks. The OSI model features 7 layers, each with a unique role. The TCP/IP model simplifies this into 4 layers. Both models are crucial for understanding network communication. They differ in structure and real-world application. Protocols are rules for communication between systems. Early protocols like IPX and SPX evolved into the TCP/IP standard. Layered protocol stacks offer modularity. The TCP/IP suite is named after its core protocols. TCP and IP protocols ensure interoperability across diverse devices. Connectivity enables devices to communicate via network media. Data transmission involves sending packets across networks. Protocols govern data exchange, ensuring consistent communication. Addressing identifies devices using unique IP addresses. Topology affects network performance and scalability. Security is vital for protecting data from unauthorized access. Measures like firewalls and encryption safeguard networks. Authentication and access control are essential. As networks grow, security becomes more complex. Ensuring secure communication is a fundamental network principle. The OSI model standardizes network communication with 7 layers. Each layer has a specific function, from physical transmission to application services. The model is idealized and used for teaching and troubleshooting. It provides a clear separation of functions. Understanding OSI layers is crucial for network design. This is a main call-out for this scene. It brings into focus the core idea being discussed. The TCP/IP model is practical and used in real networks. It combines OSI layers into 4 broader layers. The application layer handles user interaction and data formatting. The transport layer manages communication and reliability. Networking and link layers handle routing and physical transmission. The OSI model has 7 layers, while TCP/IP has 4. OSI is theoretical, offering a detailed view of networking. TCP/IP is practical, supporting real-world communication. OSI is used for learning and design. TCP/IP for implementation. TCP/IP underpins modern network communication. Protocols define data formatting and transmission rules. Early proprietary protocols lacked scalability. TCP/IP emerged as a universal, scalable standard. It supports communication across diverse networks. Protocols ensure reliable and consistent communication. TCP/IP's layered stack enhances modularity and reliability. Each layer operates independently, simplifying troubleshooting. Changes in one layer don't affect the entire system. This design supports compatibility across vendors. Layered stacks enable network expansion and maintenance. A protocol suite is a collection of related protocols. TCP/IP suite includes protocols for complete communication. Application layer protocols provide network services. Transport layer protocols manage data flow and reliability. Networking and link layers handle addressing and transmission. Application layer protocols allow access to network services. SMTP and POP3 are used for email communication. HTTP enables web data transfer. Each protocol relies on lower layers for functionality. They ensure user-level applications can interact with networks. TCP and UDP are key transport layer protocols. TCP is connection-oriented, ensuring reliable data delivery. UDP is connectionless, offering faster transmission. TCP suits applications needing data accuracy. UDP is ideal for real-time applications prioritizing speed. The Internet Protocol operates at the networking layer. It assigns logical addresses and routes data packets. IP doesn't guarantee delivery, but ensures correct routing. It uses routing mechanisms to forward packets. IP's simplicity aids global scalability. Ethernet defines data frame transmission over networks. MAC addresses uniquely identify network interfaces. ARP maps IP to MAC addresses for local device discovery. These protocols enable reliable data movement over physical media. They ensure efficient local delivery. TCP, IP protocols enable communication across layers. Application protocols provide services like web browsing. Transport protocols manage data flow and reliability. Networking protocols handle addressing and routing. Link and physical protocols manage data transmission. Protocols solve specific communication problems. TCP focuses on reliability, IP on addressing. Protocol suites offer modular design and interoperability. Modularity allows improvements without system redesign. Protocol analysis highlights specialization and layered interaction. TCP provides reliability, ordering, and error recovery. It suits applications needing data accuracy. UDP sacrifices reliability for speed and simplicity. It's ideal for real-time applications like streaming. Protocol design balances performance and resource usage. IP is simple and unreliable, aiding scalability. It doesn't guarantee delivery or order. Complexity shifts to higher layers like TCP. IP's simplicity supports global internet growth. Complex protocols struggle to scale similarly. Ethernet, ARP, and MAC handle local delivery. MAC addresses work within local networks. IP addressing is needed for internet scalability. ARP bridges local addressing gaps. Local protocols ensure efficient data movement. Conclusion: understanding these networking principles and protocols is essential for effectively designing, managing, and troubleshooting modern network systems. Mastery of these concepts ensures reliable communication, security, and efficiency in today's interconnected digital environment. Need help or have questions? WhatsApp us at 0748436168 and our team will be happy to assist. Thanks for joining us today, and see you soon!